Hi class, today we're going to go over the quotient rule. The last couple of days we've gone through the chain rule and then the product rule. Go back and watch those videos before this, proceeding with this one. But the quotient rule is essentially the third differentiation rule that we can use to get the gradient function of any particular function we want. But we use the quotient rule if the function that we're going to do is generally in fractional form. You might remember from the product rule, I'll just put a P over here, is we could differentiate using the product rule if we have two functions, or a function that's made up of two parts that are multiplied together. Multiplication is another word for product, so we use the product rule. For this one here, we're using the quotient. A quotient, if you don't remember or you haven't heard this before, quotient's it's associated with division. Or divided by, the operation divided by, and you can see we use the quotient rule when the function we're given is made up of two functions that are one divided by the other, because usually in fractional form. So anytime you see a fraction you're asked to get a derivative, chances are you're going to be using the quotient rule 9 times out of 10. The quotient rule on your formula sheet, it looks like this here, a little bit more complicated than the product rule. However, there's a shortcut version which is given here, and I'll just write the way I would, and you're going to see me when I do the example questions. The first derivative using the quotient rule, start off with v u dash. Remember, u dash just means du dx, so that's just this term down here. Take away, so the product rule was plus, the quotient rule is always take away at the top here, uv dash, all over v squared, always over v squared. And you can see, so that's on your formula sheet, but with enough practice hopefully you can take this and remember to do it in this form here. They're the same thing, just this one's a lot easier to write when you do each question. So let's have a look at a couple of examples. We're asked to differentiate these two functions. I'll start with this one first. So we've got 3x minus 5, that's a function, 5x plus 2, that's a function. They've been put together into one function, but we're going to break that up and we're going to call this top part u and we're going to call this bottom part v. And we're going to say, well, u is 3x minus 5, and we're going to find its first derivative, which is 3, nice easy one. V is equal to 5x plus 2, and its first derivative is 5. So the first derivative of that function using the quotient rule, I'm going to write it again, vu dash minus uv dash, and I would encourage you to write this out for every question. It's good, just that repetitive nature, just so that you remember this. You're not having to refer to that formula sheet every single time you do one of these. So now, just like we did with the product rule yesterday, we substitute these 1, 2, 3, 4, 5 elements in and simplify and solve. So we'll start with v u dash. So we're putting these two elements together. Again, it's a singular term with a binomial, so we'll make sure we'll just put the binomial for now in some brackets. Take away uv dash, so we're going to combine these two elements together, and that'll be 5 outside of 3x minus 5. At the bottom, we're going to have v squared, which is this term here, all squared. Now, whenever you have a v as a binomial like it is in this question, there is never a time really where you're going to have to expand this out. So once you've done this v squared bit and put the power of 2 here, you're kind of done with that. All we're doing now is going to tidy up this top part and simplify it as much as we can. So we're going to expand those terms out. So we've got 15x plus 6. Here we're going to have minus 15x. Now minus 5 times minus 5 is plus 25. All over this squared, I'll just leave it like that for now. Tidy this up, our 15x's will cancel out, and we're going to be left with at the top 31. So our first derivative of this function is 31 all over 5x plus 2 all squared. And we're just going to leave the answer like that. That's the first derivative. What do we use the first derivative for? Just remember, it's usually to find the gradient of a tangent at any point on a curve. Once we have it in this form, we might have x equals 1 or x equals 2, some value that we would then substitute in to work out the gradient of the tangent. If we look at this second example now, it's a little bit more complicated. It's only because there's a trinomial at the top, but we'll go through. This is the way we set up every question. You write down what u is. You get its first derivative. You write down what v is. You write down what its first derivative is. And then you use the quotient rule, or the product rule, depending on what you're doing. So our quotient rule, always start with v u dash all over v squared. Do your substitution. So we're going to combine these two elements here. Now this time I've got two binomials, so it's going to be a little bit more complicated in terms of just expanding and simplifying than our last example. Minus uv dash, so it's going to be these two elements here, 3x squared, 4x cubed minus 5x. I'm running out of a little bit of room here. All over v squared, so v is this term here again. I'm going to write that in, and there is no need for us to expand this out. We're just going to leave that exactly like it's written there. So now we just want to expand this. I'm going to give myself a lot of room here. A nice big fraction. You'll have plenty more room on your page. X cubed times 12x squared, so that's going to be 12x to the power of 5. X cubed times 5 minus 1 times that term. Minus 1 times minus 5 is positive 5. And then do this last bit here, so we're going to have minus 12x to the 5. What's that? It's positive 15x cubed. And the last term there will be plus 6x, oh sorry, minus 6x squared. And again, we're just going to have that bit squared. I'll write it in. Let's have a look at, see if anything cancels here. So we've got the 12x to the power of 5s will cancel. We've got some cubic terms there, so we're going to combine them. Plus 15 minus 5, so that'll give us 10x cubed. We're going to have minus 12x squared and minus 6, so together that's minus 18x squared. Just cancel these out as I go. And we've got this constant term here, 5, so we'll pop that in, and that'll be all over x cubed minus 1 squared. And we're finished. That's our first derivative. It looks complicated, it doesn't look pretty, but we've got our first derivative. So just going back before we have a look at question 1, the key thing with the quotient rule is that it's used to differentiate any function that's in fractional form, like this, with some function at the top and the bottom. Just like we did with the product rule, we get our u and u dash, v dash. We write down the quotient rule, and then from there, once you start to do these questions, 80% of your working out is pretty much just algebraic gymnastics. So just be careful with your simplification, etc. So let's have a look. Exercise 6.09 is what I'm going to get you to do today. It's on page 310. Here's the first 3 questions. I'll quickly go through those. If you want to go try these out, obviously pause the video or go try them and then come back if you'd like to make sure you got them right. Otherwise, keep watching. So this first question, question A. I'm going to use the quotient rule. We're going to call this u, we're going to call this v. And you might remember something similar to this when we did product rule, but we're going to use the quotient rule for it today. So u dash here, got a constant term there, u dash is going to be 1, v is 2x minus 1, v dash is equal to 2. So this is going to be nice, relatively straightforward for us. v u dash minus u v dash all over v squared. So we're going to combine these two terms here. 0 times this, well that's nothing, minus this times this, which will be 2. This is looking pretty good, all over v squared. So 2x minus 1 all squared. Don't be tempted to expand that out, there's really no need. This top tidies up really nicely. And the bottom here, like so. So that's our first derivative. It's nice, easy when one of the terms is a constant. Now let's look at part B. So for part B, we're going to call the 3x here our u. We're going to call the x plus 5 our v. So u is 3x u dash is 3. V is x plus 5. V dash is equal to 1. Now if we combine them together, I'm going to I've already written that there, so I'll use it here. V times u dash, so it'll be 3 times x plus 5 minus u times v dash. So that'll be 3x times 1, which is 3x, all over v squared. V squared is the binomial x plus 5. Squaring it, and not going to touch it anymore. At the top here, we're going to get 3x plus 15 minus 3x. Now obviously those two terms will cancel, and we're going to be left with a final answer of 15 in the numerator, x plus 5 all squared. And that's our first derivative. For question C, again we're going to call this x cubed u. We're going to call the x squared minus 4 our v. So we'll go through the start of our question. And then apply the quotient rule. So v times u dash. So we're going to have a little bit expansion there. U times v dash, well that's just going to give us one term, 2x to the power 4, all over v squared. Done. At the top we'll expand that out, we'll get 3x to the power 4 minus 12x squared minus 2x to the power 4, all over that bottom term. And then to tidy that up, to finish this question, we're going to get 3 minus 2, that's going to give us 1x to the 4 minus 12x squared all over x squared minus 4 all squared. Now you could, and I probably encourage you, if it's pretty obvious in today's exercise that you could factorize the top, I would encourage you to start doing that, which would be really helpful when we get to year 12. So we could tidy this up, take x squared out as a factor here. I'll just write it up here because I've run out of room. X squared would come out in brackets here, we'd get x squared minus 12. That will be of some benefit for you going forward. So if you can do that, obviously these factorized, well there's no need for any factorization there. Last one I want to do in this video is question E. So we've got u and v. U is equal to x minus 7, so u dash is equal to 1. V is equal to x squared, so v dash will be 2x. We're going to have vu dash minus uv dash. Always with the quotient rule, if you're trying to commit this to memory, always v first and v squared at the bottom is a good way to remember it, and it's always a subtraction in the middle. Let's change to a green pen. V times u dash, so that's x squared times 1, and uv dash, so that's going to be 2x x minus 7, and all over x squared squared. Now this is, because this is not a binomial, it's just a singular term, this is one example where you can do the squared, and this will become x to the power 4. So up here we're going to have x squared minus, do the expansion here, minus 2x squared plus 14, all over x to the power 4. And we're going to have here minus x squared plus 14 all over x to the power 4. And please, 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 please don't be tempted. These will not cancel because there's no x in this term here, so that's as simplified as you're going to get it. Go ahead and try question 1, A to L. You can try some of the ones after that. There's a couple with square roots, but just for today, A to L. And then question 2 and question 3. And see how you go, and send me some questions if you need some more clarification. Have fun with that.